not objective 7, checkpoint 7, before I jump over and do objective 6. We want to find the multiplicity of the zeros of the function f of x equal to negative 4 times x plus 1/2 squared x minus 5 to the third. Now, a while ago, this one didn't work real well for me because I was looking at end behavior. But if I'm looking for zeros, if it's in factored form, my work's done, right? Because I take each one, set it equal to 0. So I'm going to have a 0 at a negative 1/2, right? Yes? And I'm going to have a 0 at a positive 5. Remember, it changes signs because I set it equal to 0 and solved for it. But at this 0, x equal negative 1/2, what's its multiplicity? Multiplicity is 2 because it's squared. That term is squared. So it means that 1/2 happens twice if I listed it out, right? And then this 0, x equal 5, has a multiplicity of 3. So what does that say to you in terms of the graph? Well, it bounces off at a negative 1/2, and it's going to cross over at 5. Good. Okay? Yeah? Up to you. 3 more ideas. Yep. Okay. So, the 6th thing that we've taught here is the intermediate value theorem. Okay? Intermediate value theorem. This is not a hard idea. Okay? It says that if f of a, now what does f of a stand for? The y value, right? Means I'm going to take some number, plug it in the equation, and I get a y back. That's what f of a stands for. And f of b means I took a different number and plugged it in the equation and got the y value back, right? So it says if f of a and f of b have opposite signs. Opposite signs means what? One's positive and one's negative. Okay, so if one's positive and one's negative, then at least one number, call it C, exists. They're just two different numbers. No, they're just two numbers, and they just happen to give me back y values, and one's positive and one's negative. Then there is a C somewhere such that f of C has to be equal to 0. If I've got a nice smooth graph, and I had one x value that gave me a negative number, and another x value that gave me a positive number, then somewhere between there they had to have done what? Gone through the x-axis. There has to be some x value where the y value is 0. That's all the intermediate value theorem says. That if I've got an x and an x, one's a positive and one's got a negative y value, y has got to be 0 at some point between them. All it says. So don't let that hang you up. Okay, checkpoint 8. Where'd that go? Says if we have a function f of x that's 3x to the third minus 10x plus 9, we want to show that a real number zero, how about, exists between x equals -3 and x equals -2. Now, if we wanted to prove that, then we can prove that with this intermediate value theorem. This is how you do it. You do 3 times -3 squared minus 10 times -3 plus 9. In other words, you figure out what f of -3 is. Okay? And so that's 9, and 9 times 3 is 27, plus 30, plus 9. So that's 66. Right? Did I do it right? And we look at what f of -2 would be. 3 times -2 to the third. Oh, that's to the third. That's not right. Messed up. Because 3 to the third is -27, and -27 times 3 is -81. Plus 30 plus 9. So it's -51, -42. Okay. And then this is 8. It's -8 times 3, which is -27, plus 20, plus 9. Did I say -27? Y'all knew I meant -24 though, right? Because 8 times 3 is 24. And so that's a +5. You've just proven that there has to be a real zero somewhere between -3 and -2. Because this one's negative and this one's positive. That's all there is to the intermediate value theorem. If they tell you to do that, that's all you do is you take one, plug it in, and then when you've got one positive and one negative answer, you have just proven that there's a real zero somewhere between -3 and -2. Then you have not proven it. Okay? So you say you cannot prove that there's a real zero between these two numbers. Might still be one. Sometimes in calculus we do a little bit of stuff where we get closer and closer together so we can try to find somewhere. Because what's happened sometimes is that you've dipped down below, but you're looking at so far out that your positives are, you're both positive. So you have to keep moving until you get one that's negative and one's positive. Okay? Turning point. A turning point is a maximum or minimum. You know, like on the quadratic equations, we got a turning point because it like dips down and goes back up, or it goes up and dips back down, like a vertex. Well, what happens with these polynomial functions is I have more than one of those. I can have several of them. And the way it works is that there can be no more than n minus 1 turning points for any polynomial function. So in other words, if you have a function that's like f of x is equal to 5x to the 4th plus 3x squared minus 4. Now, I don't know how many turning points there are for sure yet, but I know there cannot be more than 4 minus 1, which is 3. The most it can have is 3 turning points. It may have fewer, but it cannot have more than that. So that helps you check to see if you have a complete graph too. Because, you know, if you look at that and you've got 3 turning points already, there's no sense in stretching it out any further, right? Because you've found all the middle stuff. You've got a complete graph. And the very last objective that's in here is just putting all this stuff together and actually graphing a polynomial equation. So objective 8. So checkpoint 9 wants us to graph f of x equal to x to the third minus 3x squared. So, first thing we talked about was that it was a nice smooth curve, right? So if I find some points, I'm going to be able to draw a line connecting them. We talked about end behavior. What end behavior does this have? It's odd and positive, so it's going to start down and end up. Okay? The next thing we talked about was zeros, right? So if I want the zeros, I'm going to say 0 is equal to x to the third minus 3x squared. X to the squared factors out, and I'm left with x minus 3. Right? So x is equal to 0 with a multiplicity of 2, and x is equal to 3. Let me give you your assignment. Page 348, 3 through 72, multiples of 3. And you just go through here and you find these points, and you'll plot the points, and then you're just going to draw the graph.